All right, so now we're getting to the big idea of this lesson. We have figure DEFGHI. It is dilated to form figure DEFGHI prime. Okay, and the scale factor is 1/3. Whenever you see a scale factor, I want you to circle it, and I want you to write if the shape is going to get bigger or smaller. This scale factor is less than 1, so our shape is getting smaller. Now, they've told us it's a dilation, they've told us they're similar, but we have to prove it. And we have to prove it by making sure those two things are true, that the corresponding angles are congruent and the corresponding side lengths are proportional. So part A has us starting with our side lengths. So it says DE prime corresponds to side DE, and the quotient of their lengths can be written as a fraction. So whenever you see quotient, just know I need to write the fraction for the corresponding sides. Don't let that word fool you, okay? Or trip you up. So DE prime is 4 units and DE is 12 units. But I can make those numbers smaller. So I'm going to reduce, and it's usually by the smaller number in the fraction. So we're going to divide both of these by 4, and we get 1/3. This means if all of these side lengths are proportional, every single fraction has to reduce to 1/3. If not, it's not proportional and the shapes aren't similar. So let's continue. Here, they've told us all the different side lengths that we need to compare. So moving on to E, F prime, that's 2. And EF is 6. I can make those smaller by dividing by 2/2. I get 1/3. So far, we're still proportional. Moving on to FG prime, that's 3. FG, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9. I can make those smaller by dividing by 3/3. Okay, I still have 1/3. We're looking good. It's still proportional. GH is 1. GH prime, rather. And GH is 3. I don't need to reduce because there's a 1. So this is as small as it gets. And it's the right fraction. It's 1/3. HI prime is 1. HI is 3. 1/3. DI prime is 1. And DI prime is 3. So all of my corresponding sides reduced down to 1/3. So when it asks what the relationship is between those quotients, it means they're proportional. So corresponding sides are proportional. Whenever you say that, I'm always going to ask, how do you know? So you're going to say they all reduce to 1/3. There's more to this question though. How does this compare to the scale factor? Well, remember up here, our scale factor is 1/3 and our side lengths ratio is also 1/3. So we're going to say which is the same as the scale factor. And I'm going to use a capital SF for scale factor just to, because I write so big and I can't fit it all. That's part B. We were comparing our side lengths, all right? Part C asks, how do the measures of the corresponding angles compare? So let's look at these angles because that's the second part to know if our shapes are similar. In the pre-image, every single angle that we have is 90 degrees. And in our image, there's still 90 degrees. So corresponding angles are congruent, using the symbol for congruent. So what does that mean? We just proved that yes, this is a dilation, and yes, these images are similar. Why? Because one, corresponding sides are proportional, and 2, corresponding angles are congruent. Those 2 things have to be true every single time. Looking at number 4, we're going to practice and see, can you find where is the center of dilation? So you took some notes. Which picture does it look like? Give yourself a moment, press pause, try to see if you can put the center of dilation in the right place. It's here. So hopefully you saw that. Now they want us to write a similarity statement. And this is really simple because they're telling us it's for these triangles. They gave us the letters and everything. So we're going to write a statement just using our math symbols. So for triangle XYZ, we don't write the word triangle. We just draw triangle XYZ is similar to the symbol. That's the big one. That's the one in blue. Now, for the image, it's similar to triangle. We didn't change the X. So X is still X, but Y is now Y prime, and Z is now Z prime. And they told you that. So just pay attention. And that is it for this page.